So the question on this quiz asks you to take some set of data that you're given at the top of the page and to determine a quadratic equation that models that data. In other words, as you say, what we're looking for is something that has the form y equals ax squared plus bx plus c. But in the question prompt it says using the variables t and r, so we're supposed to be kind of modeling a relationship of revenue over time using this second one of the data sets up here at the top. So if I scroll back up here to the top, at the top of the quiz, there's this data set that shows you how the revenue for selling a particular product changes over time, where t is the number of years since the year 2000. So in place of x and y here, what I'm asking you to kind of think about instead is use the variable t for the independent variable and the variable r for the dependent variable. So instead of x's, I'm going to write t's, and instead of y, I'm going to write r. So we have kind of a model equation, r equals at squared plus bt plus c. And so that's what we're kind of aiming for, right? And so the question is, how do we figure out what numbers belong in the parameters a, b, and c in order to make this equation match the set of data that we have here on the page? And so your question is, how do we use technology to do that? This is a good conversation for us to be having today, because this is also the kind of technology that you're using on the projects this semester when you start with a set of data and try to get to an algebraic model. So there's a couple different ways. You can use a graphing calculator. I prefer not to, just because graphing calculators are not what you're going to have out in the workplace when you have to do this kind of stuff, like actually on the job. Generally, graphing calculators are kind of, for me, kind of an inauthentic tool. And so I prefer to either use Excel or use an online graphing calculator called Desmos. But I think Excel is probably the better tool for this. So I'm going to open up an Excel window and we'll talk through that process together here. So here in my blank Excel workbook, I'm just going to put in the values in my data set. So if I call them t and r, it doesn't matter if I use them in rows or columns. I'm just going to put them in columns here. So on this quiz, I've got 3, 7, and 10. T is measured in years since 2000, so this is 2003, 2007, 2010. And the total revenue, 27.5, 7.5, and 3. Those are measured in millions of dollars of total revenue. And so I enter my data either in rows or in columns. It really doesn't matter for us in Excel. And then I just want to generate a chart, a scatter plot, which is usually the first thing you do when trying to understand a set of data, is just get it out of the numerical and into the graphical, the visual. So I'll just highlight my data and I'll choose to insert a chart. And the kind of chart I want is a scatter plot. So you can find that if you're using the same version of Excel as I am. It's this little icon here that has just the dots in it. And I want to choose a version of a scatter plot that has just the dots and not connect the dots with any kind of line or curve. So if I do that, I think I might need to zoom back out a little bit here. If I do that, then I get a scatter plot for my data. Try to move it out of the way here. Looks something like this. And you can kind of tell, at least when I look at this, I can kind of tell that these 3 points that we're plotting, they lie on a curve. And there's probably, we hope, that there's a graph of a quadratic function. In other words, a parabola that's going to connect through all 3 of those points exactly. And to find that parabola, we just need to find the values of a, b, and c that fit this r equals at squared plus bt plus c model. Right? And it's a general fact of linear algebra, actually, in mathematics, that if you give me any 3 points, as long as 2 of those points are not directly above one another on a graph, because then my function would fail the vertical line test, but as long as that doesn't happen, any 3 points that I draw, I can find a parabola, a quadratic formula, quadratic equation that goes exactly through all 3 of those points. So we can do it by doing what you said first, which is just to try and plug in these x and y values into all 3. It's going to give us 3 equations with 3 unknowns, a, b, and c, and then we can solve for those 3 equations with 3 unknowns with a system of 3 linear equations. That's generally not the approach that I like to take in this class, because that's not a technique of algebra that we're used to using in the prerequisites to this course. I'm much more interested in us being able to do this with technology. So to do that, what I want to do is I just want to add a trend line to my graph in Excel in the same way that we add any kind of trend line. which is to right-click on one of the data points in my series and then choose Add a Trend Line. Of course, if I do that, Excel's first instinct is to add a linear trend line. So it tries first to just draw a straight line through this graph. And that's probably not what we want. At least it's not what we want in this example. It is what you want in the mini project when you're working on that first task. But for us, we want a quadratic model. And so to get a quadratic instead of a linear model for my graph, what I want is over here in the formatting options, which if you're using Excel on a PC like I am, those pop up immediately. If you're using it on a Mac, you might have to go find Format Trend Line as another right-clicking option. So you right-click on the line and then choose to format a trend line. But what we want is we want to force Excel to use a polynomial fit for my line rather than a linear fit. And specifically, we wanted to use a polynomial of order 2. Order is what Excel calls degree, right? What is the highest exponent that we wanted to use in the formula for this graph? So if we choose a polynomial fit of order 2, then you'll notice that the trend line that it draws is now a curve, and that curve actually goes through all 3 of the points that we want it to go through. So all we need then to do is tell it to show us the equation, which is this option down here on the bottom, display equation on chart. And then it displays the equation for us. A little hard to read on the screen, so I'm going to make the font a little bigger, just so we can see it. So for me, this is the way that I would prefer, I guess, if you're going to use technology to find an equation for a trend line that fits data. Use Excel, generate a scatter plot of your points, right-click and add a trend line, and then from the trend line formatting options, which if we need to get back to them for some reason, you can right-click and choose Format Trend Line. From those formatting options, choose the type of algebraic model that you want, which in this example is the polynomial of order 2. So now that we have this equation on the quiz, what I'm kind of asking you to do is just to replace the y's with r's and replace the x's with t's, so that when you use this equation in context to answer other questions later on, it helps you to keep straight which variable represents what, which one is the number of years, which one is the amount of revenue.